You can tell a lot about what a graph represents based on its movement. So is it increasing? Is it staying the same? Is it decreasing? And so in this chunk here, we're going to focus in on where it has those characteristics. So if we look at our first example here, there is a verbal description right next to it, but we can see that we're decreasing from the -2 for x. And notice we have this point here, so that means it's actually starting there. We're decreasing until we get to 0 on the x-axis, and then we're constant from 0 to 2. So there's no change there. And then we're increasing up until the x value of 4. So whatever this graph is representing, that's the behavior that it's showing here. The decreasing, staying the same for a while, and then increasing. So if we look, those points of change, so in this case, we'd have a point of change and a point of change. Those are called relative. In this case, they'd be minimums because they're at the bottom. But there's also what we call a relative maximum. And so those are the points where the function changes its direction. So, and the reason we call them relative minimums or relative maximums is because they're not the actual minimum of the graph. The actual minimum would be like the lowest point, and then the actual maximum would be the highest point. But these are just changes in direction, so that's why they're called relative. And so we have here, we're changing from decreasing to increasing in 2 spots. So there's our relative minima or minimum. Minima is just plural. And then we have a change from increasing to decreasing, increasing to decreasing, and those are your relative maxima or maximum. So what we're going to do is we're for now just going to work with a graphing utility to find these points. We will eventually talk about how to find them mathematically using our algebra, but for now we're just going to observe them using the Desmos website. If you have a graphing calculator and know how to use it, that's fine, but Desmos is super simple. You can download the app on your iPad, but you don't need to. Just going to desmos.com will get you exactly what you need. All right, so number 3, let's go ahead and let's practice deciphering where the graph is increasing, decreasing, or has a constant behavior. And it helps, it's nice that we have our iPads and we can zoom in and see exactly what's happening. So letter A, we always read from left to right, starts by increasing, and it kind of slows down its increasing, but it never stops increasing. It never gets exactly straight. It never changes direction to decreasing. So for this example, we would say that we're increasing, and you could use a couple different terms here. You could say it's increasing over the entire number line. That's what the book says. But I like to just say it's increasing from -infinity to +infinity, which means the same thing. So I'm going to say this is increasing from -infinity to +infinity. So no change in direction on letter A. Letter B, we start by increasing. So we have a chunk here where we're increasing. And because there's no like dot here at the end, this is like there's an arrow. So I would say this is increasing from -infinity up until I get to this 1 on the x-axis. So for my description on that chunk, I'm going to say we're increasing. And you can use interval notation here. So you could say we're increasing from -infinity until -1. And then we're changing the direction. And notice how I used a parenthesis there and not a bracket because it doesn't stop. It's not just equal to 1. It's going to keep going. So we're going to use a parenthesis there. And then the next chunk, we're decreasing from that -1 down. And then that x value is a +1. So we're decreasing from -1 to +1. And then we're increasing again. And then here we don't have an end. So this is like it goes on forever. And so at this point, we are increasing from the 1 on the x-axis to infinity. So I would say we are then again increasing from +1 up to infinity. So we have two different changes, so we have 3 chunks of what's happening on that graph. And our last graph, similar to our first one, except again, we don't have points at the end, so these would be like arrows. And we would have where we are increasing, so this first chunk here, we're increasing from negative infinity to the x value of 0. Remember, we're focused on the x values here, not the y values. So this x value is 0. So we're going from negative infinity to 0. So we are increasing on the interval negative infinity to 0 for x. And then we're staying constant for a while. We're staying constant from 0 to 2. So we are constant on the interval from 0 to 2. And then after that, we are decreasing from 2 to infinity. So now we are decreasing, oops, from the x value positive 2 to infinity, because we don't know how far that graph goes. So there's just some descriptions. The other thing that you'll see here that the book has is your intervals written out as a piecewise function. So this is saying from, and it figured out the equation of the line. So the green line has the equation t plus 1. And that's true whenever the t value is less than 0, which goes to negative infinity. And then it says from 0 to 2, we're on this constant y equals 1 line. And then the equation of this line would be negative t plus 3. And we can find out the equation of lines just by using a couple points. And that is true from t greater than 2 up to infinity, like we talked about. So that's an example, and we'll work with in this lesson. And the next one is piecewise functions. All right, so now let's go ahead and use a graphing utility. We're just going to go ahead and go to Desmos.com, and we're going to graph these, and we're going to approximate to 2 decimal places any relative minimum or maximum points. So I'm going to pull in the Desmos on here. Okay, so here's my Desmos website. So if we type in, and you'll notice there's a little keyboard down here, our function negative 2x squared. So negative 2x, and then for squared, you can just use, there's an a squared key, and then plus 9x. And we know this should look like a parabola because we know x squared is a quadratic, and we know it should open down because it's a negative in the 2x squared. So if we scroll and we go to where the graph changes direction, if you just click on that point, it'll tell you what that value is. And when we talk relative minimum and maximum, we just want to name that ordered pair. And so here, the directions are to go to 2 decimal places. So we would go ahead and say that this relative, and this would be a maximum, so we want to say which is which. And we could say at the point 2.25. And then because it asks for 2 decimal places, we do 10.13 for our rounding. So there's our first graph. And then you can, couple things, you can X out of that, or if you just click on the red part over here, it'll make the graph go away. So there it's back, just to the left of the function. There it's away, or you can cross it off. So now if I do the second one here, we have X, and then the square root, and so there's a square root sign towards the bottom, and that is 4 minus X. Oh, I want to get that underneath the square root there. So click under, there we go, 4 minus X. And then here on my graph, I don't see it, so I need to kind of scroll around, there we go. And so here, remember the relative is where it just changes direction. So this point down here is not anything because that doesn't change direction, it's just a stopping point. And so don't worry about that point. What we want to worry about is the point that's up here. So if we click on that point, there it is, and it's another relative maximum, and that is at 2.67. So if we go and we fill this one in, this is a relative max at 2.67, and 3.08. So there's our second graph. And then our third graph, if we go and we click on the third spot here, or again, there's, if I can cross it off too, either way is fine. Here we have x to the third minus 6x squared plus 15. So if we go in here, we do, now to do to the third power, hit x, and then you'll do your a to the b power, and then that will allow you to put an exponent. And then you're just going to want to use the right arrow right underneath the functions key to get your cursor out of the exponent. And then minus 6x squared plus 15. Oops, I need to get my x squared. X squared, there we go, plus 15. All right, so there's our third and last function. And if we scroll out, we need to zoom out so we can just kind of pinch, oops, sorry. Still getting used to, there we go. We can just kind of pinch our graph so we can see what happens. And so here we have two changes of direction. We have one up top and we have one at the bottom, and we can click on each of those. So our relative maximum is at the point 0, 15. And then we have a relative minimum as well, and that is down at 4, negative 17. So Desmos is a pretty user-friendly program. You've maybe used it before, and we'll look at different features of it as we go on. So here's how we can use it to find the relative maximum and relative minimum points.